Hello everyone, welcome to Learn ReactJS for front-end development by CodeChef. In today's lesson, we'll be looking at managing complex state with useReducer, a hook that allows you to organize your logic when multiple states are interacting with each other. You might begin with a simple useState hook, but as conditions grow, such as handling scores and multiple values together, then your code might become a bit messier. This is where the useReducer hook comes in. It gives a more clean and structured way to handle these using actions and a central reducer function. So in this lesson, let us look at how the useReducer hook works step by step. So let's begin. Today we'll understand how to manage complex state in React using useReducer. We'll look at why multiple states become messy, how reducers organize logic, and how switch case improves readability. When applications grow, different pieces of state start affecting each other. Event handlers become filled with conditions and updates, and this makes the component harder to read and maintain. useReducer helps centralize that logic. useReducer is an alternative to useState for complex scenarios. Instead of directly setting values, we describe what happened using actions, and the reducer calculates the next state. Now state is the data your component stores. Actions describes events like increment or reset. The reducer is a function that decides how state changes, and dispatch is the function that sends actions to the reducer. Now first we initialize useReducer, then a user action happens. We dispatch an action, and the reducer receives the current state in action. And finally it returns a new state and React re-renders. Now why use useReducer? It keeps logic organized in one place and makes reducers easy to test because they are plain functions, and improves predictability during debugging. Reducers must always return the same output for the same input. They should not create side effects like API calls or random values because React may run them multiple times. An impure reducer might generate random IDs inside the reducer. A pure approach generates the ID before dispatching, and the reducer simply uses that value. Instead of long if-else chains, we use switch action type. Each case handles one action and returns a new state object. Now why use switch case? It makes reducers easier to scan and is the common industry pattern. Each action has a clearly separated logic block. Now that we understood how switch case organizes reducer logic, let's look at a practical example, a simple counter built using useReducer. Let's go step by step. At the top, we first import useReducer from React. Then we define our initial state using this line. This is the starting value of our counter. The state is an object with one property, count. Next comes the reducer function, which receives two parameters, the current state and action, which is an object describing what happened. Right now, the switch statement is set up, but the cases are missing. That means when an action is dispatched, the reducer logs the action type, but it doesn't actually change the state yet. So the buttons won't work properly until we define those cases. Inside the counter component, we use this particular line, and this gives us the current state and the dispatch function. Each button calls dispatch with a specific action type, which is decrement, reset, or increment. Now notice something important. The component doesn't change the state directly, it only describes what happened. The reducer decides how the state changes. Now let's look at the completed reducer. Now in the first case, which is increment, when the reducer receives this action, it returns a brand new object, which is count state count plus 1. We are not modifying state count directly. We are returning a new state object. This immutability is critical because React detects updates by checking object references. And we have our next case, decrement, which is the same pattern. Return a new object where count is reduced by 1. Then the reset case. Here we return count 0. This resets the counter back to its initial value. We could also return initial state directly. Both approaches work because they return a new reference. Finally, the default case. If an unknown action type is received, we return the existing state unchanged. This keeps the reducer predictable and safe. Notice how clean this structure is. Each action has its own clearly defined block. There is no nested logic inside the component, and all state transitions are centralized in one place. This is exactly why switch case is the preferred structure for reducers, especially as applications grow and actions increase. And that's how we use switch case inside useReducer to keep state logic organized and scalable. So that wraps up our lesson about managing complex state with the useReducer hook. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson, and I'll see you in the next one. Thank you.